Hello guys, welcome to my channel Code with Anish. Today we will learn how to develop an AWS serverless application using Lambda, SQS, S3 and SES service of the AWS. So let's first see the use case for this serverless application. So assume in an e-commerce web service, once the customer completes a payment for an order, then an invoice has to be generated and emailed to the customers. Now coming to this invoice generation. So invoice generation is what? We're converting a data into a PDF format. So this is basically a CPU and memory intensive task. So putting this task in the web service is not an advice, because this web service is a real-time e-commerce web service where we will receive a lot of real-time requests, real-time orders. It has to process a real-time order, complete the payment and provide response to the customer. So if you put this PDF generation, this invoice PDF generation also in this web service, this will slow down all these real-time requests and results in a bad user experience. So what should be the solution? So how now we can generate a PDF once the customer completes his payment? So what we have to do, this invoice generation task has to be processed outside of this real-time web service. So what, either as a separate backend service or as a serverless application. Okay, so now we have two options. So now why we are going with serverless application? So with this serverless architecture, we do not need to worry about purchasing, provisioning and managing the backend service. It is pay as you go. So which means we are only charged for what we use. So if you are not using that serverless architecture or serverless service, we will not be charged anything. Only when we use, we will be charged for that. Also, code only runs when the backend functions are required, because in this case, whenever a PDF generation is required, at that time only the code will run. But if you go with a dedicated backend service for this thing, we should make this backend service always live, 24/7 it should be live, because we don't know when the PDF request will come to generate the PDF. The request will come, we don't know. So it should be always running in the backend. But here, irrespective of any time it will come, at that time only the code will run, and we have to charge only for that point when the code is used. So that's a advantage of using serverless application. Now, no server management. So serverless framework, it doesn't mean that there is no server. Server is there, but only thing is the servers are managed by the cloud providers and not us, because if you want to run some application, serverless application, we don't want to worry about the server. The server, all thing will be provided by the cloud provider only. We just want to upload the code and run it there, and also it will, whenever required, it will be run. So no server management. And scaling of application, depending whenever the load is high, it will scale. We don't want to do any configuration. This will be also taken care by the cloud provider only. So with this, all these facilities provided by serverless architecture, what, our DevOps investment will be reduced. So we don't want to maintain a server, configure it, manage it. So that DevOps task will be reduced. With this thing, the cost will be also reduced, and we can attain the requirement, whatever function we are going to do, in a less cost as compared to if you do the same in the backend service. So this is why we opt serverless application for these cases. So this case is something where we need to generate the invoice once the customer completes the order payment. So now let's design this flow, how we can achieve this. So the architecture, so here it is. It's just a simple architecture. So as I told earlier, we have the e-commerce web service which will be running 24/7, which will process the customer order, and once the order is completed and the payment is done, so we will have the invoice details. The invoice details like the total amount he paid, the total item he purchased, and his personal details like his name, email IDs and all that. So that detail, what we have to do, we have to send to our serverless architecture. So how we achieve that? So we can use SQS service of the AWS. So SQS is nothing, it's a simple queue service. So it's a queue here where the web service will be now a producer. It will produce a message and send to this queue. So once this message is sent, that's all, because it's a queue is always a decoupling application. It will not couple this service with whatever producer which will produce whatever consumer to consumer message. It completely decouples that. So just the e-commerce web service has to generate the invoice detail, send the invoice detail to the SQS queue. So once the message is received in the SQS, what it will do? It will trigger a Lambda function. So Lambda function is what? Where our serverless application resides, or the serverless application, the functionality works in the Lambda. This is a service provided by AWS, Lambda. So here is where the actual logic will be working for generating. So this Lambda function, this we can call as a serverless application. This application will be triggered whenever a message is received in the SQS. So on triggering this thing, at that time this function will read the message from the SQS queue. So till the time this function will not work, and as I explained in the previous slide, like the code will not work there and we don't want to pay. So whenever a message come only, it will trigger this Lambda function. On triggering, it will read the message from the queue and process it. Okay, so here what it has to do on receiving this message, this customer invoice detail, it has to convert this invoice detail. So assume it will be in a JSON format. That format has to be converted to a PDF. You have to use some library to generate the PDF. Okay, so this Lambda supports many programming languages. So like Python, Node.js, Java, like that. So in our case, we will be writing the application or the functionality in Java only. Once after writing in the Java, we will upload that code to this Lambda function, and this Lambda function will store that code, and whenever it receives the request, it will process that code. So here we will write a code to generate the PDF from this invoice message, and then what? After generating the PDF, we upload this PDF to a service called S3. S3 is nothing, simple storage service, which is a storage bucket provided by the AWS. So here we can store any files like PDF, images, anything we can store as a file in this S3. And this can be, on storing there, it will give an URL. With that URL, we can access that file. So that's the purpose of this S3. So we generate the PDF and upload it. Why? Because we are using storage here, because the customer can again request for the same invoice, right? Because he shopped one day, maybe after 1 week, we send the email, but he may lose that in the email. So what, he can again re-request it. So once he re-requests, then again we don't want to generate it again, because generation is again little CPU and memory intensive task. Instead, with that invoice reference, we can fetch it from there, because after generating the PDF, we are storing in the S3. So that's the purpose, we are storing in the S3, and then fetch that URL. After fetching the URL, we will create an email with that PDF URL. So after creating the email with the URL, we have to send that email to the customer. So sending email to the customer, AWS has provided a service called SES service, which is simple email service. So simple email service is not a mail server as such. It is just a service which facilitates the sending of email from our AWS services to the outside email servers. So because sending an email requires a lot of throttling process and all, and we have to, if you are not using SES service, we have to maintain the credential of the email server which we are using to send and all. But with this SES, that is not required. We need to authorize the email ID which will be used by us to send the email to the customer. So that we can authorize in the SES service. So after authorizing that, this can be called in any function, Lambda or anywhere. We can call it, and then we don't want to give the credential. Whatever the authorized email is there, we can use that email to send the actual mail to the outside email server. So that's why we are using the SES. So after generating the email, we use the SES service and send the email to the customer. So this is the technical design which we will be using for this serverless application. Okay. So next we can have the sequential flow. So in the Lambda function, what to be done. So I already explained there in the technical design, but still once again we will see how the flow, so that once we develop the code, we can just directly use this flow and write the piece of code there. So what we get the invoice detail from the web service to SQS, and SQS to the Lambda function reads that message from the queue here. So once we get the message, what we do, we need to check for this detail we received, already the PDF is generated. So if it is yes, so how we can check is, we will ask the web service only, because what are the cases we will receive the request to generate and only to email, because to generate is where the customer initially placed the order. So at that time they can send a request saying a boolean flag saying that this is for this request you should generate and email it. Next case is where the customer lost his PDF, invoice PDF for an order. So he can re-request it. So in that request from the web service, what the web service can send is just an invoice reference and a flag saying that no need to generate, only fetch this invoice associated with this reference and send to that. So from the request, we will check, is this request is for only sending the PDF or generating and sending. So if it is for generating and sending, what we do, means is PDF is not already generated, then what we do, we will call the process which will generate the PDF, and after generating the PDF we will upload it to the S3. Then what, we have to fetch this URL again. There that logic will be called if the request is only for sending the email. So both this, after generating also it will come to this flow. If the request is also only for sending the PDF, it will come here. So here in this process it will fetch the PDF. So for an already existing thing, using the reference it will fetch. For the currently generated thing, there also when we generated, we have the reference, using that we will fetch. So both the reference here and here it will be same only, because it's for the same customer and the same invoice. So it will fetch that URL. So the URL is nothing which is a PDF. So once we get the URL, we will call another process, a piece of code which will create an email template with this PDF URL. Because now we have the URL, we don't want to attach the hardcode PDF again here, because it will be increase the mail size and all, because we just sending the PDF URL, it will be a public URL which the customer can access from anywhere. Once he get the email, he click it, he can download then and there to his machine only. Instead of sending us attachment, making the email size bigger, it is advised to send only the URL which the customer can click from the email and download it. So we attach that PDF URL and then send it to the SES service. So as I told, it is not as a mail server and all, it is just a service which facilitates sending of mail from our AWS to the outside mail. So we just call this service and it will take care of sending that to the appropriate customer. So this is the sequential flow. So now what we do, this much thing, whatever given the dotted red, has to be written by us in a programming language, and that code has to be uploaded to the Lambda service. So on uploading that, and then what should we do? We should create an SQS queue, SQS service and a queue there, and then we have to integrate this queue with the Lambda function. That's after integrating only, whenever a SQS receive a message, it will trigger the Lambda function to read it. And then we have to give adequate permission between this SQS and Lambda function, and from the Lambda function to upload a file and to get the file from S3, we have to create another permission. Same way, from the Lambda function to call the SES service, we have to create adequate permission. So this much thing we have to do, and then we can test it. So first we will see the code which will do this process to generate the PDF and upload to S3 and fetch that PDF and create an email and send the email to the customer via SES. So this code I'm written in Java. So I will show you how the code works. Also, before jumping into the code, I will also show you the demo PDF template. So how the PDF should look, means the process here, in this process where the PDF is generated, I will show you a demo how it should look. So this is the PDF format which we are expecting to generate from our code and to send to the customer. Something, the format are like company name, which is the company where the customer purchased, or where the e-commerce service belongs to, that company name and its address. And then bill to, here the customer name and customer address, then an invoice number and an invoice date. So this invoice number, this will be the reference with which if the PDF is fetched from the S3. So this invoice number should be sent from the web service only, which is calling. So we have the invoice number and the invoice date, the date the customer has completed the order or purchase and complete the order, that date. Then the items like 1, 2, 3, etc. And the item name and the amount, and if any discount and total amount. This is the PDF we have to generate using our Lambda function and send to the customer. It's just a dummy PDF only, just for our reference purpose. So now we'll just jump to the Java code and see how this can be attained. So here is our Java code. So basically we have to create a Maven project only. So I have created a Maven project and the POM I have defined. I have used Java 21 only. Because why is Java 21? Because Lambda functions also support Java 21 runtime. So I have written the program also in Java 21. Now the dependency, the main dependency first we have to add is this AWS Lambda Java core. So these libraries are required so that only whenever a message is received in the Lambda function, corresponding code in our program will be called, the corresponding code will be called using this library only. So whichever code implementing this library, there only the message will receive. I will show you that. So we need this library for that to support the Lambda services, and this one also event, because this Lambda is like an event based function. As here also in the SQS, whenever it trigger only the code will start. Till the time the code will be idle, it will not be working. When we trigger, it will start. Actually, Java program means it will start the Java program on receiving the trigger. Then it will read the message and process here in the code. So we need the event based library also. These all are from AWS only. And then we need the AWS SDK. So because as I told in the design, we have to upload the file to S3 and download the file from S3. So we need this S3 libraries to do that. And then SES, as I told, to send the email to the service to send the email. So we need the SES also. So this many dependencies are from Amazon side, AWS side. And whenever we use the SDK, what AWS they want us to use the dependency management here. So to use the BOM here. So by using the BOM, what we attain is we maintain the same version for all the SDK libraries. Otherwise, without BOM, what if we define here, we made use one version of this thing, one version of this thing, and now both these artifacts depend on another library. So due to the version used here and version used here, there will be a conflict. To avoid that only, if we use the BOM and we define the version, so all the libraries will be of the same version, which is dependent on the main version 2.25.69. So that's the purpose of using a BOM and then refer. Now here S3, SES, now many other services we can use, we can add the dependency accordingly. No need of version, because version is managed in the dependency management by the BOM. So that's all for the AWS side. So now coming, we need a library to generate the PDF. So for this, I have created a library called PDF generator. So this PDF generator, I have created the library from the PDF box. There is a library called PDF box, but PDF box is not straightforward to generate a PDF using the PDF box. It's very difficult to write the code. So what I thought was, I use a wrapper library. I generate a wrapper library with which we can make it easy to generate the PDF. Because in the PDF box, it's like line by line. If you take a PDF, you have to write line by line what has to come here, what has to come displayed here. Okay, maybe I will show that example. Okay, here if you see, if you are using the actual PDF box library, this line we have to write, then this line, and this line we have to position here and here. When it comes here, we have to position. This is very difficult if you write the PDF. You can achieve it, but it's very difficult. But instead, what I used was, I create a wrapper class which will be based upon table, row, column concept. Because if you see, we can consider this to as one table with two rows, right here, because this is one table, this is one row, this is another row, because both the row and this is the column. So it's like a table with two row and a single column, and so we can define like that. Same way, when we come here also, this many things I can keep as one table, and I can define as multiple rows, 1 2. So this is a table with 4 rows and 2 columns. Same way here, it's anyway we are displaying as a table only, so it's like a table with 4 rows, 1 header and 3 columns. So this way, with the table concept, I written a wrapper class, so the wherever the client is using to generate PDF, they can create a table, row, column and send to this wrapper functionality which I developed, the library which I developed. That in turn will use the PDF box function to write line by line. Okay, so that line by line will be hidden from the client side. Client just want to create a table, assign the value and send it. Then it's like a more native side of that will be done in the wrapper class only. So that's a one-time coding. Otherwise, that kind of coding have to create again and again whenever we use to generate PDF. So that's why I create a wrapper class as a reusable interface. So it can be used in any project to create the PDF. Okay, so this is a dependency, anyone can download it. It's in the Maven Central only. I have uploaded it there, and you can use it. So this is the one core part where the PDF generation happens using this library. And next, I have used Jackson here. Because why I use Jackson? Because we receive the invoice detail request in the JSON format only. To convert that into a Java object, I need a Jackson thing. So this much about the dependency. Now we need a plugin for build. This also, we use the Maven shade plugin. So using this shade plugin only, we finally generate the jar file, which is serverless invoice generator, and this jar file will be uploaded to the Lambda function and will be used there to generate the PDF and send the email. So that's all the form structure. Now coming to the code. So we should have an entry point. Correct. This entry point is where the message received in the Lambda function will be injected to our code. So this is done. So we have to write a class which should implement the request handler. So that's where this will come into picture, this Lambda core and the Lambda events, this library. So this request handler and this SQS event, this belongs to that two libraries. So we implement this thing and we override its abstract method. So with this thing, Lambda function will know, Lambda function actually will call the request handler whenever it receives a message. So we are implementing the request handler here, so that the function which calls the Lambda function which calls the handler of this this application will reach here. We get an SQS event here. So once we get the event, so event will have the body will have the messages. So then we can write all our logic which is required here. What we have to generate the invoice, upload the S3 and send the PDF URL. So we handle the request and we get here, because here why we are using SQS records, because we can whenever we what do you say relate this SQS and Lambda, because whenever a SQS message come, it has to trigger the Lambda, then only Lambda will read the message. So that thing we can give in a batch size. Instead of single message triggering the Lambda, we can have a batch size, like when we receive 10 message, you trigger the Lambda, and we will define a time also, either 10 message or within 10 seconds, whichever comes first. For example, first we will get 10 message within 10 seconds. For example, in 5 seconds we got 10 message, then it will trigger it. But assume even in 10 seconds we got only 2 message, then after, when the 10 second is passed, it will send whatever 2 messages there in the queue to this Lambda function. So that's configuration is there when we relate this SQS and Lambda for the trigger functionality. When we relate, we can define which either as a batch or as a 10 or as a time, whichever comes first. Either if I say batch size is 10 and time as 10 second, if the 10 second is received first or the 10 message is received first, on that this will be handled. That's only it is given record. So if for example assume in our case we got 10 records and 10 record is sent, so it will iterate through each record, and we want to, so each record is a customer invoice detail for which we have to generate the PDF. So I created a method called process message, which will be processing for each message, which each message is nothing a customer invoice detail. So here just giving the log here. So log can, here is a object called context. Using that context we can write the logs. So these logs will come in the CloudWatch. CloudWatch is another service in the AWS where we can monitor the logs. So that will be generated. And now what, this message, this SQS message body is nothing whatever the invoice detail the web service is sending to the SQS. This message what we receive now in this body will contain that message, and as I told, this will be a JSON. So we are using the object mapper to convert that into a class. So here I have defined a record, a Java record, which which is the Java representation of the object. So maybe I will show you the invoice, one sample invoice details, so you will get a better picture which we expect or which we designed here. So this is the sample request. So I have given here. So here what I will need, I need an invoice metadata, customer detail, company detail, item list, total amount, discount amount. This many classes are there, so it will look like this. So invoice data here. So in the invoice data, what all I have an is invoice generated, invoice number, and invoice date. This is a metadata of invoice. So this is a flag, as I told in the design section. If this is false, only if it is false, that means invoice is not generated. We have to, as part of this request, invoice has to be generated and then sent to the customer. So that the relevance of this field. Invoice number. So invoice number and invoice date also the web service, e-commerce web service should send, because whenever they process the order and invoice number, they have to generate in and store in some table or somewhere. The only thing is, for this invoice number, a PDF has to be sent to the customer generated. So that invoice number, so that means their system and our system, everything will be synced using this same invoice number. That e-commerce, that will also store in some table for future reference of this invoice number. Same way, we are also generating a PDF based upon this invoice number. So all the system will be in sync for this invoice number, and the date when it was when the order actually happened, that date. So this grouped into invoice data. Then what, we have the customer detail. So customer details like name, address, email. So this is the email where, this is the customer email where after generating the PDF, the invoice PDF, we have to send it. So that is what received in the customer detail. Then what, we have the company detail. So company detail is the e-commerce company, right? This e-commerce service is for one company only, right? That company only is providing the e-commerce platform to the customer to shop. So that company name and company, because in the PDF, as I showed the demo, we have not only demo, if you take any invoice, we will see the company name and address in the PDF. So for that purpose, we are getting this thing. Then the item is nothing, the item the customer has purchased in this e-commerce platform. So that details that will, so that is a list of items. So item will contain serial number, item name and amount, and it's a list. So here this example 5 items are there. And then finally a total amount and total terms as shown in the demo temp PDF. This will be used to display them. So this is just a sample. This is not a real-time invoice center. Real-time we will have a lot of more data than this, but this is just for our reference purpose here. This is the request which we expect. Now next one more request is where already these data are sent and the invoice is generated and PDF is uploaded in S3. Now the customer re-requests this PDF from the web service. They have an option called request invoice again. So when that button or something is clicked from the web service, which is not our scope for this video. So when they click, we expect that web service should send the data to our serverless function with this details like invoice metadata, is invoice generated true, and the invoice number, because this is the reference using which, as I told, this is the reference using which we have the synchronization of the invoice in that service and the PDF generated in our serverless service. So we have this, and then customer detail we require, because while sending, because now even this request, what we have to fetch the already generated PDF from S3 and send an email. So for that we need this. So we expect the web service to send this request in case of only sending a already generated email, already generated PDF. So coming back here, so here that body will be converted to the invoice detail object. Okay. So then what we do? Then we will call a method called get invoice URL. So here only we will use the logic. If it is already generated, only go from the S3 service, only get the URL. No, if it is not generated, generate the PDF and then upload it to S3. Okay. So now how we use the file name. So this is the file name is what we upload to S3, and when we want to fetch also we use the same file name. This is the reference. So the file name is nothing, invoice number.pdf. So this file name we will use. If it is already generated, we call the S3 URL with this file name to fetch that already generated thing. If it is not there, same file name only, we will create the PDF and upload there, so that next time when we call with that we will get the URL. So now we will see how we generate the PDF. So we have the invoice detail, we have the file name, and this is the class which is used inside that reusable library which I told in the POM section. So we have a PDF generator class there, and we create a PDF byte array, not as a file. This class has an option to create as a file also, but this is a serverless application, so here there is no point in creating a file and saving here. If you're running in local, we can create a file and save here, but this is just create as an array, so that this array can be just sent to the S3. Okay, so what all we need is, we need a template and the file name to create this PDF array. So template is nothing, as I told earlier, template contains list of tables. Tables contain row and row contains column, as I told a little bit earlier only. So this class generate the PDF based upon the table, column, row. So here I am setting it. So first we have the company detail table, then the customer detail table. Maybe I can show that demo and explain, you will get a better picture. Okay, so here this is the company detail, where, as I told, this is a table with 2 rows and 1 column. So that's only. So we are creating a table here. So table, we are setting the column as 1. We have only 1 column in this table. And rows, look, we are adding 2 rows. So one is the company name and another is the company address. So these 2 things are coming from the input request company name. That is the final value we are setting here. So value is so we are passing the company name row. In the company name row, we will create the column. So column is the place where we set the values and we set the font size, the color, and all that we set in the column, because column is the last unit where the value is set, and that is set inside a row, so that we can align the columns accordingly, and the row is set to a table which will give a format, so that this table will be set to the template. This template is the main unit, And template, so I can say template is made up of multiple tables, tables is made up of rows, rows are made up of columns. That concept I am using. So here we have this table, this table, this table, and here on tables. This many tables will be there. Okay, so that's how the logic is. So first the company detail table, same way now the customer detail table. So here we have build to you can see customer detail table. Here you can see, look, each rows we are adding here. So build 2 is here, build 2, and column 2 is invoice number and the invoice number value, then the customer name, and corresponding is invoice date. This was 1 row and 2 row, and this is the third row. So in the third row we have the address, and that will create each column and assign to the row and with the values. So that is the customer detail table. Then the items. Item, already we have a list. We iterate to the list and we create rows, and inside each row we set the values of each item here accordingly. Then finally another single. So here I define each discount and total amount as another single table only. So that's only with single value. We can define like that, or we can define as one table and 2 rows also. Anything is possible using this library. So finally we have 1, 2, 3, 4, 5 tables. That 5 tables are set to this template, and this template is then passed to the PDF generated create white array. So there, as I told, the library which I created, take this template, iterate through this thing, and call the PDF box library where we have to write line by line. That is a complex logic. So now if you don't have this wrapper library, we have to write for each PDF. Now this PDF, tomorrow another PDF come, we have to write again line by line or dot by dot we have to write. But here with this thing, it's make life very easier. Once you get a PDF for a requirement, we can break that into a table structure. So once a table structure is ready in our mind, we can write the code like table, column, row, and then just pass to this thing. It will create a PDF out of it. Okay, so that's what the PDF service. Once this PDF service is called, what we get is we get an byte array. Okay, so this byte array we have to upload to the S3. Okay, so now if we come here, we are calling this upload content of S3 with this byte array and a file name. The file name is nothing, invoice number which we got from that and PDF. That should be unique number. So this is the, again I'm telling, this is the difference between that service, that e-commerce web service, and our serverless system. So we receive here, and now what we do is, for using S3 service, we need an S3 client. So client, we have to define the region, and we need the bucket name also, because in an S3 we can create multiple buckets. So to define which bucket these files are going, we have to define a bucket name also. So what I did is, this kind of values I have put in the config.properties, because this can change. So I have given the S3 bucket name and a key prefix, because it's a folder. So inside this bucket, it should be stored in this folder. All the invoice should be stored in this folder. So that's what given here, bucket and prefix, that we are setting here. So we created the so key how we create the key prefix, that is the folder under the bucket, plus the file name. File name is the invoice number.pdf. So we created that key, and this key is assigned here. So we create a put object where we specify the bucket. So means this object is, this request is to put the file in this bucket with a key name as this. Key name is nothing, the key prefix, that is invoice store / the file name invoice number.pdf. So it will create, because the key number should be unique. And we are giving a read access, public read access, because this has to be accessed by the customer. Correct. If you give a private access, it cannot be read by that. Only whoever is owner of that bucket can read it. But here it has to be given to the customer. So we are giving us a public read access, and then we are building. So with that we will get the put request, because uploading a file is called put there. Retrieving is called get. So we are putting there, and then we use the S3 client, and we call the put object method where we give the put object request and what? The content. Now we have the request metadata. What all bucket, what is the key or the file name, and what is the access control list, which is public read. That metadata is there. And now what is the content? Real content is still the byte content. So that we are calling a method called request body from. This is also from the AWS SDK only, and we pass the byte. So it will create the actual request body and then it will put here. So this method only will upload this file content to the S3. So now we upload that. So once after uploading, we need the URL, get URL. So that is defined here. This is why I defined here, because this get URL is called in the other scenario. So the other scenario where the customer already generated the invoice, now he is requesting to get the PDF. So that is the condition given here. So that get URL. That only get URL is created as a public method here. So it can be called after uploading or only when it is needed to send the email, as shown in that technical diagram. So get URL also here we just whatever key created here, the same key we want here to get the URL. So key is nothing, the key prefix with the file name. So when calling from here, we already have the file name, key prefix is here. So calling from here also we have the file name and the key prefix is here. So the key prefix, file name, we call a get URL request. Same, we need the bucket and the key only. We don't need other metadata because we're just fetching only. We are not uploading it. So we give the bucket name and the key name. And it will create a request, and then what? We need the S3 client and dot get URL. We call this method. It will give an string URL. So that's what it is. So either upload or just to get the URL, we will get finally this URL for both the flow, like only to get send the email or both generate and send URL. We finally have put an if else condition here and got the URL. So once the URL is ready, then subsequent flow is same. What we have to create an email template and send to the customer. So this URL we are returning here. That's what, again coming back to the process message. So we got the URL. Now what? Sent email. So sent email, again I have created an email service class where we will send what all we need. We need the email, the customer email which we received in the request, right? So here in this invoice detail, if you go to customer, we have the email, this email. So that email and the name also, because whenever we send a mail, we need to address that person, right? Hello, hi, name. So that's what we need, the name and we need the email and the invoice URL which we got just now after generating or just after fetching that URL, and we are calling this sent email. So sent email, as I told, we are using the SES service of AWS because we are not writing our own logic where we want to provide the credential of our email address handle, not required. AWS has provided that option via SES. So we just want to use the SES service only, and whatever from email address, that is our email address, has to be authorized in the SES service. So when we open the SES service, I will show you that. So SES service is authorized, that address you can give here. So here I have given my email ID only here. This is from address. In a real-time example and all, it will be something like no reply at thecompany.com. Unfortunately, I don't have an Outlook server. That's only I have given my Gmail ID. If we have our own company email ID, we can use that only. Only thing is we have to authorize that mail in the SES service. Once authorized, we can use in other services like Lambda and all like this. So we have this thing, email request, and destination 2 is nothing. 2 is what we receive in the request, the customer's email ID, the customer's name, and then we are building a message here. So message will contains subject, a body. The subject is nothing, your recent shopping invoice. That's all the subject is here, and data is HTML data because we are now giving a button only in the email, so that when they click that button, the PDF should be generated. So for creating button and all, plain text data will not be sufficient. We need a HTML template only. So the HTML template is there. Here you can see template. Hello, the customer name. It will say thanks for shopping us. Please click below button to download the invoice of recent shopping. And we have given a button with the style with some styles here like orange color and all, and we have given the button click option as invoice URL which we just generated or which we fetched from the S3. So this will be set as the body of the email. Okay, and we build this. So we got the email request, and now we use the SES client. So this is from the SES library defined in the POM, and we send the mail. And then what, it will go to the SES service. SES service will check whether this email address which we are using from is authorized and all, and send it. Okay, so that will take care of the rest. So coming back here, we send it. That's all. So the mail will be sent to the customer. So that's all. It's just a little bit simple code only. So this, now our code is ready. Next, what we have to do? We have to build the jar out of it and upload this jar to the AWS Lambda function. Okay. So before that, what we do is we will see how to create the permission. As I told you, we need in this Lambda function, we need a permission for the Lambda to access the SQS, access the S3, and access the SES, because this code does all these things, right? SQS, it will trigger that. So we are not using anything here, but to trigger the Lambda, and Lambda have to read the message from SQS. So that permission should be there. And here we are explicitly using the S3 and SES services. So if only the permission is there, when this code runs in Lambda, it will work. If the permission is not there, for example here and all, if you give upload this and all, it will get failed there, because it will say access denied. Same way with the SES also. If when we send the mail here, it will fail because it's SES client. So this permission has to be there. So let's see how to create the permission first. Okay, let's log into the AWS management console to create the roles and permission for this Lambda function. This is my AWS management console. So here I should take this IAM service. So here you should select this roles. So in this role, you should click create role, and you have to select this AWS service, and in this service you have to give this Lambda, and then you have to click the next button, and here you have to add the permissions. So basically we need 3 permissions. So one is between the SQS and the Lambda function, another is for Lambda function and the S3, and another one is for SES. So these 3 roles, permissions, we have to add to this Lambda services. First one, this one, AWS Lambda SQS queue execution rule. So these permissions, by adding this permission to the Lambda only, it can read this SQS rule, SQS queue, whenever it receives a trigger from the SQS. So this one, so if you can see the permission here, so it got this receive message, delete message, get queue attribute. These are the 3 permissions with the SQS. And then this is logs, because of course for any Lambda function we need the logs, because whenever this event takes place, this should be logged accordingly. So that's what it is. This is an additional permission comes along with the SQS permission. So mainly important is this 3 only. Okay, so this one, and next now we need to have the permission with the S3. So we can give this permission only AWS S3 full access, so that our Lambda function can put our or upload the file to S3, and same way download the file from S3. So this is something like we are giving the full access for this S3 here, and S3 object Lambda. These 2 things are there. So this one, and now with the SES. This one, AWS SES. So AWS SES full access. This also give the full access to the SES service. So that 3, and then we have to click the next, and then post we have to give a role name. So my role name is something like Lambda invoice generator role. I'll give like that, invoice generator, and then you click the create role button. It will create this role with these 3 permission, as you can see here. So this role, as the 3 permission which we added are here. So that's all. Now what we have to do is we have to keep this ARN. This ARN is AWS resource name, the resource name associated with this role. This ARN we should keep handy because this is required in the further processes. So after creating the roles, keep this ARN handy. So that's all. So coming back to the code here, now we have the roles for this Lambda function. Now we have to build this Lambda function, this application, and upload to the Lambda function. So to build it, we have to run the same, it's a Maven project only. So Maven clean package only we have to run. So we'll go to the edit configuration, we'll come to the Maven, and here we have to give clean package and this option shade, because we're using the shade plugin. So using shade. Now if you run this, okay, and if you run, okay, the build is finished, and if you can see the target folder, you will see the serverless invoice generator. This jar we have to upload to the Lambda function. So either we can go to the AWS console and create the Lambda function and then upload this code, or we can create the Lambda function from our console itself. So from here, from this terminal. So I will be using the terminal to create our Lambda function and upload this code. So the format, the syntax to create a Lambda function and upload the code is, okay. So this is the AWS command to create the function from our console, from our terminal client side, from our client, and create in the AWS side. So it's like AWS Lambda create function and the parameter function name, and we have to give our function name. And then we have to give the runtime. So this is a Java code, so we give the Java runtime, which will be 21. Then handler is nothing, this class, as I told, this is the entry point where the message will be received. So this class, the full package name class and the method name, handle request. So this full package name class and the method name we have to specify in the handler. And the timeout. So timeout, this is an important thing because an Lambda function, it is an event based thing. So once an event is triggered and Lambda function start execution, the maximum time a Lambda function execute is only 15 minutes. That is what they have given, because it is just a event based thing. One event maximum time is 15 minutes. So we can set the time with time which is less than that 50 minutes. So if we feel like this function, our application will finish in 1 minute, we can set here. But anyway, in our application, we will set as 5 minutes only, which will be 300 seconds will give, because the invoice generation comes in a batch. So we will just give 5 minutes of bandwidth to generate that. And the role, yeah, this is what, as I told, the roles which we create a name, it's ARN we have to give here. And now then the zip file we have to give file B :// then post that this jar file. So basically, if you run from here, this command, the jar file will be inside the folder target and this name. So that path we have to give here. So this is the command, and using this command, it will create the Lambda function and upload our jar file also to the Lambda function. That's all. So I have given the command here, AWS Lambda create function. The function name is Lambda invoice generator, Java runtime 21, and the handler, the full package name org.code with Anish, SQS event handler, and the method handle request, and timeout 300 seconds, which means 5 minutes, and the role which we created, the role name, and then the zip file corresponds to file B target serverless invoice generator. So now on running this, it will create the Lambda function in the AWS and upload this jar file. Okay, now coming here, Lambda invoice generator, this function has been created. This I have already created. I just show the demo only in that command line. This I have already created and kept here. So this is generated, and if you can see the code, its size is 21 MB and its Java runtime is 21, and the handler which we specified here. And now if you come to the configurations, and see the general configuration. The timeout is 5 minutes, that's what we have set here. And then permission also, we have given the permissions which we want to create. So which cloud, as I told, the CloudWatch logs by defaultly it comes with this SQS permission, and then the S3, SES and the SQS. So whatever permissions we require to run our application has been added to the Lambda functions. Okay, and also we can see the logs here in the CloudWatch. So you can come to the CloudWatch, you can select the log and the log groups. So when you select the log groups, you can see a log group with the same name of your Lambda function. Okay. So something like this, AWS Lambda invoice generator. And whenever the Lambda function gets triggered, the logs will come here and we can open the logs and see what's happening there. Okay. So now the Lambda function and its logs, we are able to see. Now what we do, we need to create an SQS queue and add the trigger here. So I have already added that. You can see here, look, SQS, this is here. You can click the add trigger and add here, or I will show you from the command line also. So first let's create an SQS queue. So this is a simple queue service. Should come here and you should click this create queue button, and then here you have to give the queue name. So I will give the name as invoice detail queue, and here this visibility timeout is important here. Here this time should be greater than the timeout of the Lambda function. So because that much time the message will be available here to read by the Lambda function. So we have to give us, since we kept 300 there, we have to give us 301. Then remaining everything we can kept it like that, and we can click the create queue button. So it will create the queue as shown here. So like this, it will get created, and okay, so you can see here this timeout we have set 5 minutes as well, 301 seconds, which is 5 minutes. This should be greater than the timeout of that queue. And here also keep this ARN handy, because this is required, because this is the resource name for this queue. So now when we integrate this queue with this Lambda function, so that this can trigger the Lambda on receiving the message, so this ARN is required. Okay, so post creating the queue details, we can now try to integrate this, which is called event source mapping between this SQS queue and Lambda. Let's see how we can do that. So this is the command for creating that link or the event source mapping. So it's like AWS Lambda create event source mapping, and the function name, the Lambda function which just now created, and the event source ARN, which is nothing, the ARN of SQS, the queue which we created now, that ARN. So if we give this command, it will create the event source mapping. So it's like the AWS Lambda create event source mapping. The function name is Lambda invoice generator, and the event source ARN is this one, what we have created now. If you run this, it will create the trigger there. Post running, if you come here, you will see this event trigger like this SQS queue linked to this Lambda invoice generator. Okay, and you can see the configuration here, the invoice detail queue, and its state is enabled, and it is linked to this Lambda invoice generator. So with this thing now, whatever message received in the queue will be capable of triggering this Lambda invoice generator, so that the Lambda invoice function will start. And this what we do with the, since the permission is added there, it can access this SQS and read the message. And once reading the message, we have already upload the code here. It will invoke the code where that handler, as we have seen here. This handler will be called, and once the handler is called, whatever logic we have written there, it will process. Now one more thing, assume we have so now till this time we haven't published this version. This version is because now whenever we upload this change, it will impact, for example, to make it stable like a production release. So to make it production release, what we have to do is we have to come to the version and we have to publish like a new version. So when we publish a new version, whatever the latest code which we have uploaded here, that will be taken and create as a version here. So for example, when we give here, we can give something like version 1. We give here like version 1, and if I publish here, you can see Lambda invoice generate .1. So this is a version 1. So now what we are doing is our Lambda function name got changed. So wherever we want to, now we have to look, there is no trigger here. So maybe I can create the trigger for this command and see if it creating the trigger here. So in this thing, what I have to give is I have to change the name to :1. So now if I run this, it should create the trigger. Look, I will get the queue here. So this queue, now whenever a message comes, this will trigger this also. So that's how it works. What advantage of creating this version is, now even if someone upload a new code also, it will not impact this version. This is like a production release. Now only after again going to the version, and when he publish a new version only, it will get impacted. So this is how it works with the version. Okay. And now, as I told, uploading the new codes, how we can, so for example, whenever we have added some more changes in this code, now how will we upload that? So upload also we have a command. Similarly, AWS Lambda, we have to give update instead of create function, update function code, then the function name, and again after making the change, we have to build this Java project. So it will create a jar again. Then you have to give. Just only thing is we have to make sure the change the command as update function code and give the function name and the zip file. So the new change will be uploaded here. With publishing the new version, that change will not impact here. This will be like a production release. It will not get impacted. So once we uploaded here, if we publish a new version only, this change will get impacted. But till that time, the new code can be tested with this name, Lambda invoice generated. The published version will have, now if I publish one more version, it will be like version 2, and this published version will be only published if the code has been changed. If there is no code change and if I try to publish new version, it will not publish. Only if you have update the code and try to publish only, it will create a new version here. Anyway, time being, I will delete this version because we want to test with the test code only, not with the published version. So I will delete it. Okay, so now we have only this Lambda. Just I showed you to just make how a production version, because this is a test environment, so I can upload frequent times to test it, so it will not get impacted. So publishing, we can create a stable version which will not be impacted by the subsequent upload code. So now in this case, this whatever message comes with SQS queue will be triggered this function only, this non-published function only. Fine. Now what we need to create a bucket. As you see in our code, we will be uploading our file to a bucket called this code with Anish. So this bucket has to be created. Goes to the S3. So after coming here to S3, you have to click create bucket and give the bucket name. Okay, so here we will give the bucket name, and then we have to give ACL enable, because as you see in our code, we will give the read-only access control list to the object inside this bucket. So we will give this object ACLs enabled and keep object writer as the object owner of this bucket. And then we can also disable this public access. So click this thing. So we have to enable this ACL. We have to make the object writer as the owner and enable the public access, means remove the block on the public access. And that's all, and we have to click the create bucket button. So a bucket will be created like this, and now we can use this. So already the permission has been added to Lambda to upload anything to the bucket. That full access has been given. So this, and in the code also we refer this bucket name. So the S3 part is done. Now what we need? We need the SES to send the mail. As I told, we have to authorize an email ID, so that can be used in our Lambda function to send the mail to the outside email network, any outside email. So we have to configure that. So for that, we will come here, we will give SES, which is Amazon Simple Email Service. So we come here and click get started, and once getting started, we have to come to the identity, and we have to click create identity. So here you can give its domain name or email address. So you can give the email address and enter this email address which you want to use to send mail, and then you click the create identity. So once post create identity, whatever email address we have given here, AWS will send a message to that email ID to verify that. So post clicking that verify button, you can see that identity here as verified. Same way you can give the domain name also. Unfortunately, I don't have an email domain name because. And also there is one more limitation. This is in the sandbox. Like if you can see in this because using sandbox and we are not a production ready. Only once the request production is to get production ready. So in the testing environment, there is one restriction, like there are some restrictions like 200 emails per 24 hours period, 1 email per second. Some restrictions are there, some throttling is there. In addition to that, we can also send a mail to the from the AWS function, we can send to a mail also to an authorized email only. We cannot send to anywhere. That's only the limitation sandbox, not in the production. Once in the production is ready, we can send to any outside email. So here also only the authorized email only we can send it. So that's only. So anyway, I have used this code with Anish only as the authorized email. So in our test, in our application, customer email address also I will use the same thing, and the email address which we want to send also same, means I will be in fact it is like sending from same mail and receiving the same mail. But in production environment we can test with any customer email. So since it's a testing environment only, I am using the same email for both the customer as well as in the code to send the mail also. Okay, so that's all for the SES. So what is the requirement? Requirement is like the e-commerce platform will send the message to this queue, and this queue in turn will do whatever we explained till now. So we don't have an e-commerce web service. That is an out of scope for our video, but we can simulate that. Simulate how we can use the send and receive option in this queue. So using this, we can enter the message body and send it. So this is something similar to e-commerce, that web service sending message to our queue. Just we can simulate that. So that is our intention, is just to make sure if a message comes to our SQS queue, it will reach the Lambda function, and Lambda function generate the PDF and send an email to the customer. That's what we need to test. Okay. So we will take the body. So as shown earlier while walking through the code itself, this same body we will take. So this has all the content required to generate the email and send the email to the customer. So the customer email address is here. As I told, I am using the same email address only because due to the limitation of the testing environment. I will put here. Okay. And now I will click send message. On clicking the send message, whatever technical architecture I have shown, the sequential flow, the code walkthrough, everything should be executed and we should receive an email. Let's see, send. So message has been sent and is ready to be. Now what happened? The trigger will be received in the SQS, and SQS will try to receive this message. So let's see the flow. So we have to come here, we have to refresh the log stream. Yeah, the log is created, and let's see if it is working fine or not. Okay, look, the message has received and processing the invoice detail message. Here, this processing. So that means the Lambda has read the message from the queue and it started processing. Okay, looking good. These are the block which is written in our PDF generator, where we generate the PDF out of it. So it looks, it's a little bit intensive task. Suppose that what we do, we will create the email. So that is done here. Sorry, we will generate the invoice URL, and that URL, so we should get a message like invoice URL equal to. So you can see our URL, we have received the URL. This is what given here. So that means PDF has been generated, and the generated PDF has been uploaded here. So uploaded, and after uploading we will get the URL. So that URL is printed here. Now what? After uploading, then send that URL we will get here, and that URL will be sent as an email. Okay, fine. The email sent successfully. That is what we have printed here. So we got the processed message, and then we got the invoice URL, and that is sent successfully. Now we can go to my Outlook. So I am expecting a message with that PDF format there. So let's go to the okay, first maybe I will show the S3 also, in the bucket also, how the message get generated. So we will go to, yeah, you can see this invoice store folder, and inside the folder we got the PDF. So the invoice number given is 27B3, on unique number. So I am creating with that unique number of the PDF. Okay, so bucket also come, and as we see in the log, it has only, since it is there only, that URL has been generated, and that URL is sent as an email. And you can see in my inbox, I have got the email. Look, hello Anish Kumar SS. Thanks for shopping us. And the subject, your recent shopping invoice. So that's what given in the code also. Your subject is your recent shopping invoice. And the content is hello, the name. So hello Anish Kumar. Thanks for shopping with us. Please click the below button, down the invoice. Now if I click that invoice button, I should get the invoice with the details present in this request. I click the download invoice. Fine. Code with Anish. This is a company name. So company name is here in this detail, company, and the address, FGH Lane, POI Street, LMO City, Postal. Yeah. And bill to Anish Kumar SS. This Anish Kumar SS. So ABC House, LDA City, code this one, and the address is this one. So the address also come here. And then invoice number is this, and the invoice date. So that also printed here, and the item. So I have 5 item A, B, X, Y, F. So A, B, X, Y, F, and its serial numbers 1, 2, 3, 4, 5, 1, 2, 3, and the amount 100, 200, 50, 300, all that amount 100, 200, 50, 300. The total amount and total discount. Total amount is 800. Total discount. So that's how the PDF is generated, and it has received in my Outlook also. So that's all. That's we have finished the flow. Now maybe I will give one more flow for this thing already generated. I will give this request, and this also I expect I don't need to regenerate. I expect the same PDF has to be fetched and sent back to me. So coming back here, the queue, I will just send this. Now we are expecting the e-commerce web service to send this request when the use customer just re-requested the invoice. So is invoice generated as true, and the invoice number, that is important. This is a unique reference between that system and the system to identify the actual invoice. Okay, so now when we click this send message button, again this message is also now ready to be received, that the Lambda trigger is again done. Let's see it will start working or not. So we got the processing invoice. So the request will come here only. So the first the processing invoice detail. Now here only when we get the invoice trigger, it will check this condition. So in our case, this will be true. So we will not create and upload. We will just get based upon that invoice name. Okay, it's calling that, and look here we are not generated. Earlier you can see the PDF generation, some other logs has come and then upload to S3. Here nothing. It just called the S3 and got the PDF. So this URL. That's what given here, URL. Now what email send. So this is the other logs for authenticating to the SES service and calling that, and you can see the email sent successfully, which is shown here. So email sent successfully. Now again I will open my Outlook and see if I receive the to message. Yes, I have again got the new message also, and this time again the same content. So when I click the download invoice, look, it will see the same email. Okay, so that's all. So we have what we designed, we have achieved now using this SQS, Lambda, S3 and SES service. So we create an application which is like a serverless application, and as you've seen, it will be triggered only when it is needed, and it is completely separated from the main service, the main e-commerce web service, and it runs independently, and it whatever it's intended to do, it has done successfully. It created the PDF, stored in the S3 bucket for the reuse, and then sent an email to the customer with that attachment PDF. So that's all for today's video. I hope you have liked this video. So in the next video I will come with more content, more variety content, and till then, bye, take care.